Hello there, welcome to lesson number 4 in our series on creating bracelets using FluidDesigner for 3D printing. Today's lesson we're going to show you how you can use a Torus Knot curve to create a bracelet. So if you start FluidDesigner up, we need to go to Learning Projects, Jewellery Projects, Bracelets. We're doing lesson number 4, so it's 04 Torus Knot, so you can drag and drop that object onto the workspace. I'll just switch on the screencast key, so any key presses I make should be displayed in the window down here. And just remind you that the help instructions are in the help window here. So this is the object that we're going to create, this Torus Knot bracelet, and we're going to do it by using Add Curve Torus Knot Plus. So we're going to use a curve. So if we go to Add Curve Torus Knot Plus, this adds many types of knots. And what's important is that this window here opens up. At the moment the object in the center of the screen is really tiny. It's just 5mm by 5mm. That's much too small. But if we go to View and Zoom to Selected, you can see what the object is. So a torus knot is a continuous curving object. So the default object looks like that. We're going to transform it into the object that's shown at the bottom there. So first of all, what do we need to do? Well, if we look in the help window, we'll keep the resolution at 100. The higher this is, the smoother the final surface will be of the object. We won't worry about that in this lesson. We're going to change the height to 20. So I could just click here and change it, or I could type in. Alternatively, if I just hold down the left mouse button and drag the mouse to the right, you can see the height changing. And if I just set it at 10 for the moment, you can see over here in the properties window the value for Z. The blue arrow is the Z direction. The value for Z is 20 when the height is 10. So in other words, the 10 refers to this height up to here, but it's also 10 below the grid. So it gives us a total height of 20. So we want a height of 20 here according to the help instructions. So we can drag this up to 20. Or the more accurate way to do it is to click in there and to type 20. And notice that that gives us a height of not exactly 40 but pretty close. So the height value is in fact double the value that's shown here. Now I should point out that when we change these other values at the bottom, P and Q, this height may well change. Okay, so it's not an absolute value. You can always go back to it later and change it, however. So what's the next thing that we want to do? Well, we want to set the scale to 14. Scale to 14. Well, let me change it slowly, or drag the mouse across, and you can see the scale is actually changing the width of this object, or from the point of view of this being a bracelet, we're changing the inner diameter of the object. The smaller the scale, the smaller the inner diameter of the object is. We want to change this up to 14. So I'm going to actually type in 14. Now, if we look in the X and Y dimensions over here, they're 57mm. We've only got a scale of 14. What we find with this value, the scale value, we need to multiply it by 4, not double it. We need to multiply it by 4 to get the X and Y values, in other words, the inner diameter. So a scale value of 14 gives us an inner diameter to our bracelet of about 55mm, 56mm, something that sort of order. So the height, it's double the value, but the scale is 4 times the value. Now these may well change as we change the P and Q values. The next thing, however, I'm going to change is the bevel. And if I just zoom in first of all, You can see the thickness of this object. It's quite small at the moment because this is actually controlled by the bevel. And as I change this bevel value, you can see the thickness of the each strand is increasing. And I'm going to change it to a bevel of 1, so I'm actually going to type it in as 1, and that actually gives us a thickness of 2 or 2 millimeters for the finished object. So a bevel of 1 gives us a thickness of 2 millimeters. We're now going to change the P and the Q values, these two values here, and I'll just modify that window slightly. So if I change P from 2 to 3, you can see the shape of my torus knot changes, and constantly as I change the P value, the shape of this object will change and we'll get a different torus knot. Now, according to the help instructions here, we want P to be 5 and we want Q to be 14. Well, as you can see, as I change Q as well, that also changes this torus knot. So there's a lot of functionality here. There's a lot of different types of knot that you can actually get by changing these P and Q values. Now if we look over here at Z, Z was 40 millimeters before. It has shrunk slightly as we've changed these P and Q values. It was 2 times 20 before. It's slightly less than that now. And the scale value, well, 58 is 4 times 14. That's changed very slightly as well, but we did change the thickness. That's pretty much the same object now. So we've set these values here. Now once you're happy with this style and general shape and size of it, this needs to be confirmed, it needs to be applied. Well, what we did when we created this object initially, we added a curve. Now we can't print curves. We added a Torus Knot Plus curve. We can't print curves. What we need to do is to convert curves into meshes, and we can do that in FluidDesigner by going to Tools, Object Tools, and Convert to Mesh. Now when we do that, these values will be fixed and we won't be able to change them anymore. So if we go to Tools, Object Tools, and convert it to a mesh, notice that this window changes, the object changes to a white colour, and now we've pretty much got our finished object. So what can we do next? Well, we could delete the object at the bottom. We can highlight that and press the X key on the keyboard and delete it. Now if we have a specific dimension for the internal diameter, we could go to View and view it from the top. I'm in perspective mode at the moment. It looks a little bit strange this at the moment because we're in perspective mode. If we go to View and toggle it and change it from perspective to ortho, we need to be in ortho when we measure. Okay, let me just switch it back to perspective again. You can see perspective. Perspective means viewing it in the distance. So one side of the object, the diameter of it looks different from the other because we're looking at an object as though it's in the distance in perspective. We want to change to ortho when we measure and view it from the top again. And so we can measure the inside of this now using the ruler. And so the interactive ruler tells us that that is 52 millimeters. Okay, so I'll press the escape key to cancel that. If we wanted to set this inner diameter to be, let's say, 45 millimeters, a way of doing it is just scroll back along the toolbar. If we add a mesh, if we add a cylinder, and let's say we want a bracelet of 45 millimeters internal diameter, if we set this value, the X value, to 45 millimeters and the Y value to 45 millimeters, and I'll just increase the Z value so you can clearly see the cylinder sticking through the mesh, sticking through the torus knot. What we need to do is we need to now scale the torus knot down to fit just on the outside of this cylinder. First of all, however, go to View and Top. And we'll just zoom in slightly. Check that you are in ortho. Highlight the Torus Knot. Make sure the Torus Knot is highlighted. You can see that as Torus Knot object here. And we want to scale it now. So if we press the S key on the keyboard and scale it, and as we move the mouse in, we're scaling it down, and we want to just be on the outside of that cylinder. Now, whenever you scale anything in FluidDesigner, always look in the toolbox panel and look for resize. And we've got a vector values of 0.881. When we scale in FluidDesigner, the scale factor changes, and we've always got to reset this back to 1. And we do that with the object still highlighted. Hold down the Control key and press A, and apply the scale. The scale has been applied, so that resets the scale factor back to 1, and that's very important from the point of view of 3D printing. If you're just using FluidDesigner or Blender as the background engine is, just to create objects, it's not so important, but when you want to print, it's vital to reset that back to 1. So we can now delete this cylinder. Make sure the cylinder is selected by pressing the X key on the keyboard. We need to save our Torus Knot. So as usual in FluidDesigner, go to File and Save As. Go up through the menu system. Go to My Projects, Jewellery Projects, Bracelets, and we can save Lesson 04 Torus Knot Plus as a Blender file. Now we can't print Blender files, so we need to export it as a wavefront object or as an STL file sometimes, but we use wavefront, and then check it using NetFab Basic. So you go to File, Export. We like to use wavefront OBJ file format. We save it to the desktop as Torus Knot Plus OBJ. So we've exported that in a printable file format. Go to NetFab Basic, which is free on the internet, and go to Project and Open. Go to the desktop, open Torus Knot 04 Torus Knot Plus, and you can see we haven't got any warning red triangles here. This object should be printable, but we always recommend you go to Extras and repair the part. NetFab will in fact triangulate the mesh. These triangles here have been created by NetFab Basic, and if I just move my screen across and just click Update, you can see there are no border edge problems, no orientation and no holes. This object has got 19,000 triangles in it. That's the as you can see, quite a lot, 19,000. That's just how it's been produced automatically for you. But always run automatic repair and execute it in NetFab Basic. Click Update. There's still no problems with the edges, orientation or holes. I wouldn't have expected it when using curve function. So click Apply Repair and remove the old part. And now this is a printable file format, a printable mesh. We've checked it in NetFab. All we need to do is to save it. So go to Part, export the part as a wavefront object, export it to the desktop, and save it with the little extra name repaired. That's the file that you should print. Okay, so that's the end of today's lesson. We've used a Torus Knot plus curve to create a simple bracelet. Thank you.